you very much, and sorry for my voice, or exactly what remains of my voice. So, we are dealing about, we are going to speak about megacities, and in general, we are going to analyze what is a megacity, which are the main challenges, and just to depict a road for sustainability in megacities. I will show you some past and current research that we are developing here in Lucca, and some work in progress. So, it's a common claim that we are living in the century of urbanization. So since 2007, people is more urban than rural. And according to the United Nations perspectives, in 2030, there will be about 41 or more than 40 megacities, and especially in Africa and Latin America and Asia, urban population will grow even faster. Okay. Urbanization is, as of today, at the same time a challenge and an opportunity. As we can say from this graph that is courtesy of Professor Chris Kennedy, as urban population increases, also increases the need of energy of the whole urban system. The problem and the challenge is that by 2050, as Angel was saying, more than 60% of the global population will be urban. This means that from now to 2050, 2.5 billion people will belong to the urban realm, and will consume energy. We need all the infrastructure and housing to live in the city. And now the challenge is to reduce the impact and the environmental impact of megacities and in general of the global urban system, provided the fact that about 70, in my estimates are about 80%, but 70% of greenhouse gas emissions come from cities. The opportunity is huge for both for the progress of the mankind, but also for business and also for policymakers, because these 2.5 billion people that will become urban will need basic services. So someone will have to provide these services from them. And they also need to rely on clean energy sources. They will contribute to the global economic development of the world, especially from low-income areas. And so we have also to reduce emissions from that. So it's straightforward that the model that we use to develop our cities up of today is no more suitable. So we have to project and we have to adopt another model which is based on sustainable development. But exactly what is a megacity? You may imagine the skyline of New York, of Rio. These are megacities, but especially for the cities that become megacities in the last 2 or 3 decades, the common scenario is the lower one. Degraded soil, slum, traffic congestion, and so on. So a megacity is an object that is defined as an urban agglomeration counting more than 10 million inhabitants, is considered the paradigm of the first urban evolution for the next decades. Megacities behave like accumulation points. So the model of urbanization, especially in developing countries, is not the diffused city. Is the concentration of several 10 million people in one point. One example in Africa is Lagos. Lagos is a huge city surrounded by almost nothing. And megacities are also a hub, so they are very important points for the global network of cities. And they, especially for small countries, but also for fast developing countries, they concentrate and represent a large amount of the economy of the country. By example, Seoul concentrates 50% or something like that of the global of the GDP of the whole South Korea, or Tokyo concentrates about 40% of the global population of Japan. So study megacities means understanding which is the future of urbanization in fast developing countries, and understanding how they use and consume energy is crucial for the future development of infrastructures. But on the other side, megacities, because of their size, amplify all the issues related to urbanization. So formation of slums, environmental pollution, inadequate infrastructural systems, and so on. This is just to show that in a commercial network of the world, megacities represent very important spatial accumulation points. These graphics come from a study that we developed in cooperation with Chris Kennedy from the University of Victoria. At that time I was in Enel Foundation. We have computed the global impact of megacities. So you can see, from here you can see that 27 cities as of 2011 concentrate about 7% of the global population, and this 7% contribute to about the double of the global GDP. So just think about that 27 cities out of the old cities of the world contribute to 14% of the global GDP, as well as contributing to the 11% of waste disposal, about 10% of electricity use, and so on. So the impact of these cities is much greater with respect to their size, with respect to the global population. There are a lot of infrastructural challenges, especially because of the fact that a city that grows very rapidly, as occurred in Latin America in the last 20 years, or as it is occurring now in Asia or Africa, this fast growing makes infrastructure inadequate. So the quality of life in emerging megacities, excluding for a small part of people, is very poor. So people does not have access to electricity. Water is a concept that is far different from our. So I have friends in China, or also friends in Latin America, say that water is something wet coming out of the pipes, but it's not for drinking. By example, just to give some figures, all the megacities are concentrated in zones where flood risk or water risk is very high, as was pointed out also by the World Resources Institute that analyzed all the water risk for the global area in the next decades. Of course, pressure on environment is huge. The 10 most polluted cities in the world are all megacities and are all located in that area. Slums are a common phenomenon for megacities. So I don't know if you know, slum is just the informal cities made of barracks, where people lack on living space. Basic services are absent or are very limited. I'm speaking about energy, access to sanitated water, road networks, telecommunications, and so on. Also, the access to high efficient energy sources is very limited. So people cook by means of biomass or by means of coal. Each day, about 10,000 people die because of indoor air pollution. So these are the challenges which are it's not so easy to cope with. And then we are working to propose a sort of road to sustainability for megacities. And this road is composed by several parts that are still ongoing. So we have to identify which are the structural changes. We have to shift our vision and consider city as complex systems to understand their energy and material flows, because pressure on environment means that these cities consume and use energy in a more, to consume in a more efficient way. We are developing the concept of low carbon electric city, and there is the strong need to provide the policymakers with decision support tools. So cities are, the first step is to consider cities as complex systems. Is something straightforward, just to think about that a city is not something very simple, because is a set of multi-layered interconnected infrastructures, both hard and both soft. So people is living, is interacting, infrastructure are interacting. So it's not easy to trace and to understand what's going on under the dynamical point of view. Furthermore, there is the role of cultural and technical evolution that is very hard to be simulated with standard or, how to say, linear techniques. Just to give you an example, we may think about energy networks, road networks, water networks, telecommunication networks, as networks that are interconnected and need to be more integrated in order to optimize and in order to make cities more resilient and more friendly for people. One of the key concepts that we are using to develop this framework is to consider the urban metabolism as a tool for understanding what is going on cities. It's just we start from considering a similarity between a city in general, an urban system and a living system. So there are an inflow, outflows, and so we have people, food, materials, and other flows that are incoming into the city. These flows are transformed, and they produce waste under the form of solid waste, gas, not used heat, and so on. And urban metabolism in the last 10 to 15 years is getting more and more importance, because it's very easy to understand also for policymakers, so they do not need to understand very complex or very difficult concepts, and is a common framework both for sustainable and planned design and greenhouse gas inventories. So what we did, this is an example of the flows that are incoming into a city. What we did is to analyze study the urban metabolism of the 27 megacities as of 2011. We published these results on a PNAS paper. And this is an example of what we can do by considering the city as something for which solutions should be tailored. And in order to tailor solutions for a city, we have to understand what's going on in the city under the point of view of the flows. For example, these are some of the results that we can say, and we can see that if we compute a share of all the flows inside the cities, we see that New York, which is a city of about 20 million people, produces the 20% of the all waste of the other megacities. So we are saying that New York produces wastes in double with respect to Tokyo, which is a city of about the double of population. Or in China, there are some anomalous flows in water. But another thing that we can see very, very easily from this graph is that access is critical to consumption. So the last cities which are ranked to GDP, Kolkata, Karachi, Dhaka, and Lagos, are cities that, with respect to the population, consume much less with respect to other cities with less people. This means that this is a problem of inequality. It's just a problem of inequality. For example, in Mumbai and also Dhaka and Lagos, about 60% of people lives in barrack. are not inserted in the formal society. We also are developing the concept of low-carbon electric cities. So the ideal set is to have a city that consumes a high amount of energy under the point of view of electricity, because electricity is the fuel, is the energy form which is more efficient under the point of view of transportation, consumption, and flexibility of use. And this electricity should be provided by low-carbon sources. In the set of megacities that we analyzed, 3 cities plus Paris are located in Latin America and have a very green electricity mix. Paris was surprising, not the Latin American megacities, because Latin America there was a policy and there was development towards hydropower. So the ideal position would be in the lower right corner, and we are developing the concept of electric city. No, sono andato sotto. Then we developed a set of key performance indicators that should be able to capture all these issues and all these solutions for megacities, and the key performance indicator that must be simple to use. Simple because some colleagues from the World Bank told us that despite the fact that there are a lot of indicators, a lot of studies that try to rank city sustainability and megacity sustainability, these indicators, this set of indicators are too wide and too difficult to understand. By example, the Siemens Green City Index is a set of 30 or something like that indicators. So this is not useful at all for a policymaker that usually needs to take fast decisions. So we decided to focus on 4 indicators that, in our opinion, are representative on how the city is behaving and the city is consuming. So the 4 indicators are electricity use per capita, the percentage of households with direct access to drinkable water, solid waste production, and percentage of population with access to internet. We are not considering the GDP as an indicator of quality of life, as an indicator of development. Because GDP is transversal and is comprised in all these indicators, and it's much more easy for a policymaker to decide and to push for investments, by example, to increase the percentage of people that have access to water or have access to electricity that push GDP. So just going to a policymaker and say, your GDP should be higher. This is not very informative. It's informative to say that in your city, 40% of people does not have access to drinkable water, or in your city, according to the population, your city is consuming a low amount of electricity because of access, because of inadequate infrastructures, and so on. This is something that we have we will do something of very touchable under the point of view of what we can do. Why electricity? We can say that from this graph, this is something of surprising, or something that surprised us, that despite of the 10-year growth of population in the range of 10 to 15%, this growth ratio is not reflected both in GDP or electricity consumption. So usually, excluding very few cases that are very specific and should be analyzed point by point, usually electricity, the increase of electricity ranges over 100%, so 10 times. GDP sometimes also 2 or more times. This means that there is a sort of superlinear scaling between population increase and all the consumption pattern of the megacity. London is a specific case because of very restrictive policies on electricity consumption, the energy consumption, the electricity consumption was reduced despite an increase of population. Per capita electricity consumption is also related to the environmental and air pollution. And also here we say where lack of electricity, lack to access of infrastructure may push down the access, the consumption. So the last cities here, these are the cities where people does not have access to electricity. So also this is another demonstration of the fact that the electricity consumption is not only is an indicator that provides and gives indication, gives insight on the whole quality of life of the city. Drinkable water is a typical example of hard and very expensive infrastructure to be installed. So we have this, we found this fit-on with the logistic model for which if there is a sort of threshold of GDP. Under a certain point of GDP, usually lack of access to drinkable water is much more relevant. I'm speaking about Lagos, Jakarta, Manila, where the situation is very bad under this point of view. Waste collection is a mean and is an indicator of how the whole infrastructure of waste collection works. And access to internet is, we use this indicator as a measure of soft infrastructures. So infrastructures that are not, does not require both capital and operational expenses to be installed. So they behave completely different. By example, while electricity and water are connected with GDP, we did not find any kind of relation between GDP and access, by example, to mobile phones. So by analyzing these KPIs in cooperation with our colleagues here at EMT and also in the University of Victoria, we tried to apply and to apply the community detection algorithms to megacities in order to say how these four indicators are able to group cities. The results are quite promising because we found that these KPIs produce clusters and produce community of megacities that are, in the common sense, quite reasonable, excluding New York, because it's not in the developed region. But New York is not in the developed region, not only because I don't like New York, but because of waste. Waste production in New York is too much. So with Fabio, we tried to make a sort of scenario for which New York produces half of the waste, and the cluster was modified. This may give insight to policymakers to say that your city is in this cluster, and you have to act on these measures to push and to evolve your city to another position, to another community. So why is important? It is important now to understand that these methods based on synthetic population may be very useful to provide policymakers with tools for understanding and for giving insight on future evolutions. So to simulate the behavior of people, by example, to react to policies, or analyze infrastructural changes, as we saw this morning with electric mobility. So simulate new policies. So by example, it's not easy, but it's very easy to understand that policies may be very effective on reducing the impact of impact on the environment. So by example, Moscow reduced about 5 times the impact, the consumption of water in the last 10 decades because of water conservation policies. On the other side, this is a very recent study that we are developing on Lima. The electricity generation mix in the megacity of Lima changed in the last 10 years. They switched from hydropower to natural gas, and this produced an increase of about two times and a half in the emissions of global greenhouse gases, especially CO2. So this is an example of how wrong policies or policies that do not keep in account all the connection with the environment may be very dangerous for the environment. So last but not least, of course, I'm not alone. There is a lot of people working on this stuff. So we have a network of 28 researchers worldwide based in the megacities, and now this network is composed by both scientists and people from the industry, like people from Inel and from several universities in the world. So thanks for your attention. If you have some questions, I will be happy to answer.